Assalamu alaikum. Here is a question on curvilinear motion. We have a rocket that when this rocket reaches 40-meter altitude, it begins to travel according to this function, right, which is a parabolic function. So y minus 40, everything squared equal 160x. If the y component of its velocity is constant at 180 meter per second, so given here Vy, simply 180 meter per second. Determine the magnitudes of the rocket's velocity and acceleration at the altitude of 80. So at 80 meter, we would like to find V, which is simply, the Vx squared plus Vy squared, and also the magnitude for the acceleration, which is A equals ax squared plus ay squared. Okay. Now notice the following, that since Vy is constant, right, I can immediately conclude that Ay is 0. Okay. Okay, now let me start to find the unknowns. I would like to find Vx and I would like to find Ax. And now this one is already 0 and this one is already known. So this one is given, right? So I would like to find this, right, and this. Okay, now let us start immediately by differentiating this expression. But now we have to be careful about that we are doing the derivative with respect to time. So we need to use that we are doing dy over dt, right? And here we have also the power rule for differentiation. So now let me apply the power rule for this side. So taking the derivative with respect to time, I will have 2y minus 40. Now taking the derivative of what is between the bracket will be simply y dot, or dy over dt. So now I'm going to use this notation. Y dot simply is dy over dt, and the same goes for x dot, dx over dt. And if I take the derivative one more time for this, I will have y double dot simply is d over d square, y over dt square. Okay, and also x double dot will be d square x over d t square. That's the second derivative. Okay, so now this is equal 160. The derivative for x with respect to t will be simply just x dot. Okay, now I'm doing my calculations as the question says at 80 meter. Now y dot is given, right, and y is required to be at 80, so I can find x dot. So but just by replacing that here, I will have 2 times 80 minus 40 times 180 equal 160 x dot. And now we can find x dot. I did my calculations and found x dot to be 90 meter per second. Everything here, by the way, is in meter. Okay, now we have find x dot, so now we can find the velocity magnitude. So v will be 90 square plus 180 square. Okay, got number 201.2 meter per second. Okay, now for the acceleration, what do we have to do? This expression here, this one, I'm going again to differentiate this one more time to find the acceleration, because you know the acceleration is y double dot and x double dot, right? So now this expression here, let us take the derivative one more time. But now we have to be careful about something here, which is the left side here. We have a product, y minus 40 as a function and y dot. So we have to use the product rule as well. So we have 2, I'll just put outside. Let me fix the first one, which is y minus 40, and take the derivative for the second one, which will be y double dot. Plus, now let me take the derivative for the first one, which will be simply just y dot, because y minus 40 is just constant. And already I have y dot, right? So it will be y dot square equal 160 x double dot. We have said that y double dot here is 0 because that's ay, right? Here. So now this term here will be 0. So now, and y dot is known, I can find now x double dot. So I did my calculations here. X double dot here, I found it to be 405 meter per second square. And again, as you said, by the way, this is just simply ax, the acceleration in the x direction. So now what will be the magnitude for the acceleration? You know, since this is 0, right? So it is simply ax squared, and so the square with the square root will cancel. So this is the same also as the magnitude for the acceleration. Okay, that's it for this video. If you find it useful, please like and share the video, and let us know in the comments if you have questions or suggestions. Wishing you all a very good luck.